I want to take a moment to go back to classwork 6, which was on standard deviation, and kind of answer those couple of questions that were a little, open-ended, more confusing. For those of you who may still be a little confused or not sure. So, number 19 from classwork 6 says, "Could the standard deviation of a data set ever be negative?" But if we think about that standard deviation formula, right, how we get it, well, we start by subtracting the mean to get the deviation. And this can be positive or negative, depending on if that value we're looking at is above or below the mean. If our value is above the mean, then it's going to be a positive number. If our value is below the mean, then it's going to be a negative number. So the deviation kind of tells us, how far and which direction. Now, the next step in that standard deviation equation is to square each of those deviations to get the squared deviation, right? So this would be our squared deviation. So when we square this, thinking back to that classwork, why did we square this? Well, we squared it because if we try to add up all those deviations, the pluses and minuses end up canceling each other out and we get 0. So our way of kind of getting around that is to square them and then later take the square root of them to undo it. But when we square them, this is turning all of those values, whether it's positive or negative, into a positive value. All right, if we put in -2, if we square -2, -2 times -2, this is going way back for some of us. Well, negative times a negative, it becomes a positive, right? So all of these values are going to be positive values at that point. So when we get a little further on, so we end up dividing by n minus 1, whatever that happens to be. Well, this isn't going to n minus 1. Is that going to be positive or negative? It's always going to be positive. The only way you could have a negative is if you had a sample size of 0 or less, which is not possible. Then you have no sample, or negative people doesn't make any sense. So this is always going to be positive. So we're taking something that is a positive, dividing by something else that's positive, we're going to get a positive. And then finally, after this step, we take that value and we take the square root of it. So we take the square root of something that's positive, and we're going to end up with something that's positive. So could the standard deviation of a data set ever be negative? No. The way we have it set up with the formula, it can never be negative. It, as we'll see in the next step, it can be 0, but it can't be negative. And what kind of helps me to think about this is I like to think about the standard deviation as kind of like a distance, as a measurement of distance. So I'm saying like about how far away in a distance are our data clustered around this mean. And so if you think about distance, you can travel forward and cover a certain distance. You can travel backwards and cover a certain distance. The distance is still going to be positive. It's not like if you walk backwards, you are walking a negative distance. You're still walking a distance, right? It's still from one point to another point, regardless of whether you're going forward or backwards. You still end up with something that, like a positive distance. So I like to think of it sort of that way, as our standard deviation is kind of like the average distance from the mean. And so if you think of it that way, distance is always positive. So our standard deviation is also always going to be positive. Now, number 20 could the standard deviation ever be 0? The answer is yes. And so there's really only one very particular case where this is going to happen. And I think it helps if you think about what is standard deviation again? What would it mean if we have a standard deviation of 0? Well, if we have a standard deviation of 0, that tells me that kind of on average, all of my data points are 0 distance away from the mean. So if I have my mean, okay, if my standard deviation is 0, then that means the average distance of all my data points from the mean is also 0. So if a data point is 0 away from the mean, that means it's right on the mean. And if they're all your data points are exactly the same as what your mean is, then you have 0 distance from that mean. They're all exactly the mean, right? So we could look at this data set 2, 2, 2, 2, 2. If we wanted to find the mean of this small data set, you could probably guess what it is, but let's go ahead and do it anyway. 2 plus 2 plus 2 plus 2 plus 2 would give us 2, 4, 6, 8, 10. And then we want to divide by how many numbers did we just add up? 1, 2, 3, 4, 5. So the mean is going to be equal to 10 divided by 2, or 10 over 5, not 2, 10 over 5. 10 divided by 5 equals 2, right? Our balancing point, if all of these are stacked up at the same spot, 2, 2, 2, 2, 2, where is our data going to balance at? It's going to balance at 2, right? And then, okay, let's find the mean. Well, the mean is just where they're balancing. I wish I had drawn that a little more accurately. And so if we look at this data set, how far away are these data points on average from that mean? They're not. They're all exactly the same as the mean. So in this case, our standard deviation would be 0. Now, if any one of these values changed, right, if one of these 2's was a 1, or if it was a 3, right, let's just say that we change 1 to a 1. Well, then we would have 9 divided by 5. Okay, 9 divided by 5, that gives us 1.8. Okay. So now our mean, instead of being at that 2, it's actually going to be a little bit over 1.8. And so in this case, none of the points are going to be exactly on the line. And so it's not going to end up being 0 because we are going to have some distance there. So the only case where you can have a standard deviation of 0 is if every single value in your data set is exactly the same. Okay, so hopefully that helped with wrapping up that class.